Hello everyone. Each term somebody asks about the horse race problem. So far 2 of you have asked, and I bet by the end of the week a bunch more would be asking if I didn't do this. So here's that problem. I've replaced horses with javelinas, which are these little pig-looking animals. Javelinas are found in the Sonoran Desert in Arizona, which is where I'm heading this week to my winter home for the first year. Yay! I'm becoming a snowbird. So I'm traveling from Wisconsin to Tucson, Arizona. It's going to be a 3-day trip, and I may see javelinas. Javelinas are these little 40-pound animals. This one's just a baby, of course, that they run in packs, kind of like rabbits or squirrels. I guess they don't run in packs, but they're just a little wild animal that live in the desert. Okay, so back to the problem. 8 javelinas are in a race. 4 of them are tied for first place, and then there are no other ties. So we have 4 in first place, and then 5th, 6th, 7th, 8th place. How many ways can the 8 javelinas cross the finish line? Well, this is not an easy problem. Here's how I analyze it. First of all, I've got my 8 little javelinas. They're running the race. And how many ways I like to think about, I like to start out saying, well, what could possibly happen? And here's what could possibly happen. We're going to have the first 4 of them are going to be tied, and then there's the second group, 4 more. So let's see. Let's just pick some random numbers. First of all, numbers 1, 3, 5, and 7 might be the ones that tie. And let's see, then they might come in, one possible order is 2, 4, 6, and 8. Well, that looks like a permutation, and we could mix the numbers up, and if we didn't have this tying thing, we were just asked there are 8 javelinas running a race and how many ways can they finish, the answer would be the permutation of 8, select 8, which that's a pretty big number, I think. Calculator, go. That's 40,320 ways. However, we don't have a permutation because these 4 are tied. Recall, what do we know about permutations? In permutations, order matters. Well, in these first 4, it doesn't matter, right? They tie. We could have had 3, 5, 1, and 7, or we could have had 7, 3, 5, 1, or many different ways. It didn't matter which way the first 4 finished. Now it does matter which way the last 4 finish. So how are we going to reconcile this? Well, because I know the problem, I know we're going to solve it as an FCP because we can't combine these things. It's not a pure permutation. It's something else. And here's what we're going to do. The number of ways that these first 4 can be chosen turns out to be a combination. Remember, in a combination, order doesn't matter. Well, that's what we have. So this first group of 4 is going to be the combination. We've got 8 javelinas, and we're selecting 4 of them. 8, select 4 combinations. All right, FCP says we multiply these other things together. We got 1, 2, 3, 4 others. Okay, we've used already 4 of our animals. So how many ways can the 5th place person be selected? Well, there's 4 left. We've already used 4 for the first 4 in first place. There's 4, and then let's see, because we're now looking at this part is like a permutation, we can't have repetition. So let's see, in the next slot, there will be only 3 choices. And then in the next slot, only 2 choices. And I left off one, I'm sorry. The last choice, there'll be only 1 javelina left to choose. There's our answer. You do the math, and let me do it again. 8 Combo 4 is 70. We've got 70 of those. Let's see, did I do that right? Yes. Times 4 times 3, that's 12 times 24. And that makes 1,680. Tricky problem. We had to first identify that there were two parts to it. There was a combination part, and there's also a permutation part. And the only way we can combine those is with the FCP, where we're embedding combinations and permutations inside of the FCP. By the way, we could have written this slightly different. We could have said that this 4321 is really the permutation of 4 objects, and we're selecting 4 of them. Let me just make sure I know what I'm talking about here. 4, select 4. Sure enough, that's our 24. And that's what 4 times 3 times 2 times 1 is. Okay. Give a holler if you have any more questions, guys. Happy to make little videos.